Okay, today we're working on practice 12.4, factoring special cases. Very similar to what we've done the last couple of days with factoring. We're still going to use the box method, even though it's called a special case. We're still going to use the same process we've been doing, and then when we get finished with the problem, I'll talk to you about why it's a special case. So let's get started. Let's draw our box. There are no common factors for this problem. For there to be a common factor, there'd have to be a coefficient in front of that n squared term right there. Since there's not, there cannot be a common factor. So n squared goes in the top left-hand corner of our box. 4 goes in the bottom right-hand corner of our box. We're going to multiply those two things together, and that's what we're going to write our factors for. 4n to the second, or 4n squared. So there's the only two sets of factors. Just like previously, we look right here. That add sign tells me that I need to add the factors. So 1n and 4n equals 5n, 2n and 2n equals 4n. And then I look at my problem, and that tells me that I need positive 4n. So to get the positive 4n, I need 2n and 2n. So that completes my box. And then we need to do our greatest common factor for our rows and columns. So on the top row, n squared and 2n have a common factor of n. On the bottom row, 2n and 4 have a common factor of 2. They're both positive because the boxes that they touch are positive. So my first binomial factor is n plus 2. When I repeat that process for the columns, my first column on the left, n squared and 2n have a common factor of n. 2n and 4, again, have a common factor of 2. They're both positive because the boxes they touch are positive. And so that binomial factor is also n plus 2. And that's what makes this a special case. This original problem right here is called a perfect square trinomial, and it factors into a binomial square, because another way of writing n plus 2 parenthesis n plus 2 would be to write n plus 2 one time with a square on the outside. So then we can go up here and we see that our correct answer is the letter B as in boy, n plus 2 with the whole thing squared, quantity squared as we say. So that's one special case. The other special case is a difference of two squares. So that means that we're going to have a perfect square, a subtract sign, and then another perfect square. Let me switch pages here. There we go. So there's, as I was saying, here's our difference of two squares right here. We have x squared, and we have a subtract sign, and 1, another perfect square. Over here we have b squared, subtract sign, and another perfect square, 4. That's what all of those difference of two squares will look like. And again, we can use our box just like we have in the past. There's no common factor in number 9. So our first term goes in the top left-hand corner, x squared. And our constant term goes in the bottom right-hand corner. We multiply those together. And the only way to get negative x squared is to have 1x times 1x to get x squared. And again, our symbol in front of the constant tells me to add or subtract. In this case, we're going to subtract. And we have a middle term of nothing. Well, there's no middle term. Normally, we have, our problem looks like something x squared plus or minus something x plus or minus some constant. Well, we don't have this x term, so that means it became 0. And that makes sense because our two numbers are 1x and 1x, and when we do what it says and we subtract, then we get our 0. That's why it's called a difference of two squares and not a trinomial. So once we get our box set up, now we're back to same-o, same-o. We do what we've been doing the whole time, and we do greatest common factor from left to right in the first row. X squared and 1x have an x in common. And the bottom row, 1x and negative 1 have a 1 in common. Both of those are positive because they touch positive boxes, so my binomial factor is x plus 1. Now to do the columns, x squared and 1x have an x in common, and then whoops, I made a mistake over here a minute ago. I didn't make one of these negative and one positive. I had to subtract, so they had to be different. So that changes that my common factor is not 1, it's now -1. And that binomial factor is going to be x minus 1. So then the correct answer, x plus 1 and x minus 1. And again, those are called the difference. The original problem is called the difference of two squares. This is a difference of two squares. And our answer is called a sum and a difference. There's the sum, there's the difference. But even though they're special cases, we really didn't change how we went about doing the problem. Hope that helped. Have a great day.